see basically two type of circular motions. One is kinematic and circular motion, dynamic and circular motion. When we talk about kinematic and circular motion, we talk about theta, omega, and these sort of things like theta. I'm sorry. Um, we deal about theta, and then we deal about omega, and then we deal about alpha, right? So, but in dynamics, we only concern about the application of the force. For example, when a force is applied to a body and body comes into motion, that is the application of the force and considering the cause of the motion. So, let's study in detail what is we basically two type of relationship: linear relation and the angular. So, let's deal with the linear. uh, for the first one that we're going to discuss is the important terminologies that is related to the linear variables. Okay, so first is linear variable and then is circular variable. Linear variables, and then the second one is here I'm going to write here. If the spelling is not right, you can correct it by yourself. So let me write it again. Linear variable, and then again next one is acceleration, linear variable, and then circular variable, right? In the circular motion, circular motion, or the circular variables, right? So, or angular variable, I could say, or angular circular variable or angular variables in the angular part. So, let's see with the linear variables. We know that the linear variables, we know about first of all position. So, position is x, then displacement. We will deal with it each and everything in detail, which is delta x. Now, I don't know how to use delta here. So that we can write here the dot x is considered as delta x. And then velocity. Velocity, I'm writing the short form. Velocity, that is equals to change in displacement, delta x divided by t, and then acceleration is equals to the dot v divided by time. So this is the linear relationships, right? For example, now I'm going to discuss about here the position. Here the in angular motion, the position is omega, something like that. I don't know how to use it omega, so we consider 0 as omega. Displacement, change in omega, displacement. So I'm gonna write it here. What does it mean? Change in dot omega, and then velocity is velocity is basically known as, okay, let me just deal it with the help of a marker. So let's do brush. So displacement is it is something like this, theta. It's not perfect. Velocity is represented by sine omega, and omega is equals to change in theta divided by t. This is basically velocity, the angular velocity. Now acceleration is represented by alpha, and alpha is equals to omega upon time. So this is basically linear variables, and this is circular variables. Now what is position? For example, considering a circle here, for a while consider a circle. Okay, let me make it a perfect diagram of circle here. So let's do it. Okay, let's make a complete perfect diagram of circle here. For a while, consider that this is basically a center of a circle. This is the center of a circle. Now the distance from center to here is known as radius. Okay. For a while, consider that the position of a body is here at a point P1. At a time T1, because body has just started its motion. Point P1 in time is equals to 0. And after a while, body moves to this point, which is point P1. In time is equals to, for a while consider, is equals to 2 seconds. Time is, I'm not able to write it perfectly, but time now is equals to 2 seconds. For a while consider it, right? So now it's making an angle theta. So this is basically we can see the body has moved through a theta angle, or there is a displacement of angle, right? So for a while we say body, for the position, 2 points are very important. First is the point of origin, It is origin. Now, firstly, I'm dealing about the what is position, point of origin. Point body has changed its position. First, this is the initial position, and it moves. It has moved here. So this is two things are very